How many times have you been delayed for maintenance, paid a high fare while still worrying about a cancellation, or had to drive far to a major hub because the airport near home kept parking the plane? The 2026 Tesla Super Electric plane shows up exactly for those headaches, aiming to shorten hangar time, cut costs per flight hour by avoiding heavy overhauls and reducing reliance on specialist crews, and bring routes back to small local airports so your trips are simpler. So, what is the what's shocking here? Could schedules default to on time instead of hoping for luck? Could fares actually soften without sacrificing reliability? And instead of getting lost in endless gate changes at big hubs, could you just fly from near home? The 2026 Tesla Super Electric plane means less waiting, less spending, and fewer hassles on ordinary trips. If you want the full story and more technology that truly touches daily life, please subscribe and turn on notifications so you never miss a new video. Now, to answer what's shocking convincingly, let us go straight to the operational core of the 2026 Tesla Super Electric plane to see what really shortens maintenance time and lowers cost. Modular Electric Propulsion Quick Swap. The Tesla Super Electric plane centers everything on modular electric propulsion pods that bundle an electric motor, an inverter, and an electric propeller with quick connectors for structure, power, data, and cooling. When a pod flags a fault, the Tesla Super Electric plane allows a 4-technician team to remove the failed pod and install a standardized spare in 4 to 8 hours. Then complete propeller balancing and a ground run for 30 to 60 minutes. Because opening a turboprop turbine for inspection often takes 3 to 10 days. This day versus hour gap is the first link in how the Tesla Super Electric plane cuts cancellations and delays. Building on that, swapping whole modules instead of deep on-wing repairs reduces maintenance man-hour per flight hour. Older turboprops often spend 4 to 6 man-hours on the power plant for each one flight hour. With no combustor, no oil system, and no large gearbox, the Tesla Super Electric plane brings that down to about 1 to 2 man-hours per one flight hour, a 50 to 75% reduction. The same modular strategy supports a stock of pre-balanced, pre-estayed spare pods. So a within-shift swap can lower power plant-driven AOG by 30 to 50% and lift on-time performance by 5 to 10 percentage points. In practice, moving from 78% on time to 86 to 88% on the Tesla Super Electric plane already means fewer rebookings and fewer unplanned overnights. While the aircraft's lighter staffing needs make small airport operations more feasible, those operational gains translate into money. If power plant maintenance represents 20 to 30% of total operating cost on short routes, trimming man-hours and hangar time with the Tesla Super Electric plane can reduce costs per seat kilometer by 15 to 25%. On a 300 kilometers leg with 19 seats at 0.20 per seat km, the total is $1,140. Under the same assumptions, the Tesla Super Electric plane can save about $200 to $250 per leg, which creates real headroom for gentler fares without giving up reliability. To keep these advantages safe and repeatable, the Tesla Super Electric plane bakes verification into every swap. Crews measure high-voltage insulation resistance, pressure test the cooling loop, perform dynamic propeller balancing, and run at multiple power levels for 30 to 60 minutes with an optional 10 to 15-minute technical flight. The aircraft records pod serials, verifies inverter firmware, and logs all results digitally, which reduces repeat issues by 20 to 30%. Logistically, stocking one spare pod per 3 airframes covers more than 95% of single-event faults in a day, while failed pods are re-certified in 2 to 3 days at a central shop. Taken together, the Tesla Super Electric plane turns a week in the hangar into a one-day turnaround. Cuts man-hours from 4 to 6 down to 1 to 2 per flight hour. Reduces AOG by 30 to 50%. Raises on-time performance by 5 to 10 points and adds 1 to 2 short-haul rotations per day, which equals a 10 to 20% frequency increase. Which benefit of the Tesla Super Electric plane matters most to you? A less waiting thanks to pod swaps in 4 to 8 hours. Be lower fares from about 1 to 2 maintenance man-hours per flight hour. See more on-time flights via predictive monitoring and OTA AOG down 30 to 50% D. Fly closer to home with standardized parts and 24 to 72-hour parts response. Comment A, B, C, or D. 2 fewer moving parts. The Tesla super electric plane leans on a simple truth about electric drive. Very few moving parts. The Tesla super electric plane uses an electric motor with only a rotor and a few bearings with no camshaft, pistons, valves, turbo, or large gearbox. In real operations, older turboprop fleets often burn 4 to 6 maintenance man-h hours for each one flight hour just for the power plant. Switching to the Tesla super electric plane can bring that to about 1 to 2 man-h hours per one flight hour, a 50 to 75% reduction in on-air airport work. For travelers, that means the Tesla super electric plane spends less time under inspection, triggers fewer cancellations, and steadily pushes on-time performance up month after month. Because the Tesla super electric plane removes entire systems that frequently cause trouble, it also removes a long list of fussy tasks. The Tesla super electric plane eliminates complex fuel systems, high-press fuel lines, multi-stage pumps, combustors, and hot turbines. That cuts periodic oil changes, oil filter debris checks, leak hunts, fuel line pressure tests, mixture tuning, turbine blade inspections, and soot cleaning. For regional fleets, A and B checks often crowd the calendar to catch early faults. Operating the Tesla super electric plane can reduce A and B check frequency by about 30 to 40%. Because oil and fuel items disappear, while C-level equivalents shift toward faster electrical diagnostics and sensor checks. The result with the Tesla super electric plane is quicker turnarounds and far fewer "please wait for maintenance" announcements at the gate. Regenerative braking adds another everyday saving. During landing and taxi, the Tesla super electric plane can use its motors for braking, converting kinetic energy to recharge the battery. By shifting part of the braking load to the motors, will brakes and landing gear see less heat and wear. On short-haul routes with many cycles per day, trimming mechanical brake workload by 20 to 30% can extend pad and gear service intervals by 25 to 40%. If a traditional brake set needs replacement after 800 to 1,000 landings, a reasonable Tesla super electric plane scenario is 1,100 to 1,400 cycles. Each deferred replacement saves several 000 in parts.